Hey guys, very good morning. Today in aerodynamic course, we are going to see the case study for effect of side spin on a football using Ansys Fluent. So in introduction, the Ansys Fluent is a computation fluid dynamics software that is used to solve various problem related to fluid flow, heat and mass transfer, chemical reaction and more. It used advanced physical models like turbulence modeling, multiphysics modeling, battery modeling, combustion, and FSI, usually we call it as fluid structure interaction, to solve the given problem to high level of accuracy. In this case study, ANSYS Fluent is used to understand the effect of spin on a football, usually we call it as scorer ball in North America, using turbulence modeling. Bernoulli's principle will be the used to explain the curvature of the ball dynamics. The description of boundary layer separation as well as the turbulent wake formulation will be visualized using Fluent post-process tool. So football is one of the most popular sports in the world with the final of the World Cup viewed by around 3.5 billion people across the globe. Football is the most important game and the ball is the most important part in this sports with the dynamics and the shape as well as size of the ball plays an important part in the skill set. The Football Association, which is formed in 1863, sets the rule for size and shape of the football in 1872. Based on the rules, the football should be spherical, circumference between 68.6 centimeter and 71 centimeter. The weight between 400 grams to 440 grams. The pressure of the football between zero point 0.6 atmosphere pressure to 1.1 atmosphere pressure at sea level condition. The earlier version of the football were made up of pig's bladder. However, later with the introduction of an inner bladder, the outer side was made up of leather stitched together. Initially, there were 6 panels that were stitched together. In this case study, the football being simulated in based on the iconic Adidas Testras which was introduction during 1970 in Mexico World Cup. This football has an 20 hexagonal and 12 pentagonal surfaces together to form the outer surface. Fluid dynamic simulation can help us to understand these challenges as well as the change in the roughness of the ball while being kicked through in the air. This case study takes one such example where there is a side spin of the football and effects on the movement of the ball, and it is done by Ansys Fluent to simulate this problem. For that, we are taking the Bernoulli's principle and the Navier-Stokes equation to understand the phenomenal understanding an equation which is consist of energy equation in the condition for steady level flow, the incompressible irrotation flow. No heat is transferred to from the fluid to the ball, and then no work done on or by the fluid. So let us take an aerofoil with the V1 and V2 different velocities. The lift is generated in the pressure difference over the aerofoil. So by the same, like the aerofoil's example, a spinning ball is considered moving in air, mimicking a free kick being taken during the game of the football. So let us take the free kick moment while the ball is spinning, the small boundary layer over the surface of the football, it's producing the direction as the football moving. The figure shows the boundary layer is flowing in the same direction of the flow on one side of the ball while it is moving through opposite direction on the other side of the ball. Because of this impact of this spinning boundary layer, the average flow velocity where the boundary layer meets the free stream will be slightly higher or lower than the free stream velocity. According to the Bernoulli's principle, the side force will be now have pressure imbalance which leads to a force being acted on the object, pushing the object in the direction of higher velocity. This phenomenon, by which there is a bending of spinning ball in the motion through air, is called a Magnus effect. This can be seen in various sports in the football, cricket, and other ball-related games. So here we are using the Ansys Fluent, and the model is made up of CAD files. That Trasera football was designed with a simple isolated structures. The size of the ball is 114.4 mm, which is equivalent to the rule was stated in the previous section. The football structure is imposed and the enclosure size of 10 cross 5 cross 5. The domain is created and the entire part is made up of the, the meshing element. The volume mesh were generated using the water trigger geometric workflow using the Ansys Fluent meshing. The detailed mesh sensitive study was carried out, and it is the very important to step in simulation to construction a mesh that will give the accurate solution for which we giving an exact result. With the mesh sensitivity technique, mesh with a total cells of 1 crore 36 lakh 72,052 elements were created. This will give a reasonable accurate value for force acting on a ball while spinning with effectively. The spin of the ball is defined under the boundary condition set in the Ansys Fluent workflow. The ball is considered as well as a ball with the motion activated to around the about the y-axis. The speed of rotation 50 radius per second, and the internal velocity of the fluid is 25 meter per second. This is usually in a open ground boundary condition. The transition pressure based calculation is carried out the Ansys Fluent using reliable K epsilon turbulence model. The real challenges facing in the football, the free kick is a very important method in the football by teams giving in the very good flow over the ball. So here we are obtaining the results, the spinning of the ball with various radius per second and the velocity and the y z direction. For 25 radius per second, we are producing force is 2.1 Newton, whereas 200 radius per second we are getting 5.5 Newton. So in real life, many factors affecting the movement of the football during the free kick, and this include the trajectory of motion of the football, the effect of various drag leading to slowdown of the football, the middleware as well as the structure of the football being a important part in the dynamics of the ball. Instead of having isohedral shape, the modern balls consist of spherical model panel of 8 to 6. This leads to have smooth surface, which resulted in the unpredictable movement of the ball in the air. The real issue, according to NASA, in the using of drag of the ball drastically reduces, leading to uncontrollable movement of the ball. In this case study, a simple side spinning ball were evaluated to understand the effect of spin in the ball. This case study only checked the effect of side spin on the ball, and more detailed analysis could be carried out to understand how the structure of the ball affected during movement in the air. Another area of the analysis which could be interesting would be know the effect of gravity on how it affected the force acting on the ball. This case study also assumed that axis of rotation is consisting during the flight of the ball. However, in reality, it shifts as a ball moves in the air, leading a different behavior of the ball during flight condition. This can be another avenue of the research in the future. Thank you.